Good afternoon and welcome. It's 3:30 here in Syracuse, and it's my pleasure to open this Research and Technology Forum of Syracuse COE to welcome folks who are here in the room and also on the web. Many of you have been with us before. You know we have a monthly program of Research and Technology Forums. It's brought to you by the Syracuse COE Partner Program. If your firm or institution is not already part of our partner program, I encourage you to talk to Tammy Rosanio. Also, Syracuse COE has an initiative that we're performing right now in partnership with Center State CEO called Thermal and Environmental Controls Innovates, Tech Innovates. As part of Tech Innovates, we have a monthly program called Tech Tuesdays. So this month's Tech Tuesday is on Wednesday, is today. So this is a joint offering of our monthly Research and Technology program and our Tech Tuesdays. For Tech Tuesdays, we typically visit sites of local companies that are involved in developing thermal and environmental controls. And we've been billing this presentation as Visiting Orlando, thanks to Bill Chadwick's presentation. You've all seen the announcement for today's presentation on the Center for Intelligent Buildings, UTC's new Center for Intelligent Buildings, which will be given by Bill Chadwick. 3 years ago, Bill gave a Research and Technology Forum here on the new HVAC system in the Sistine Chapel. And it was one of our best ever. And as part of that presentation, Bill's presentation was preceded by a presentation by a faculty member from the School of Architecture who talked about Leonardo da Vinci, the architect and the engineer, and the Sistine Chapel. So in honor of Bill's triennial presentation at our Research and Technology Forum, I thought we could, I would offer to Bill, and he kindly agreed, that I would give a presentation before Bill's, and I would talk about a brief history of HVAC in Central New York. So this is meant as a warm-up to Bill. I promised him that I will stop at 4 o'clock, which is a hard thing for me, and that Bill's presentation will begin at 4, and hopefully by then, you know, folks who are late in arriving, I can serve to be the buffer between the real show and now. So this is a presentation that I've been developing over the years, and actually I started. Howie is not in the, oh, there he is. Howie Hollander, who's the long-serving president, now president emeritus of the Technology Association of Central New York, TACNY, which has an annual lecture named after the founder of TACNY, John Edson Sweet. Howie and I gave a Sweet lecture together a couple of years ago.
The 100th anniversary.
The 100th anniversary Sweet lecture, actually, we gave together. And it was actually thanks to that invitation to join Howie in that presentation that I started to prepare a presentation on the history of engineering in Syracuse. And it's from that initial presentation that some of the slides that you'll see today came, but I've been iterating on this for various audiences. So for this audience, I'm calling the presentation From Gere's Lock to Carrier Circle, a brief history of HVAC in Central New York. And I can't start any presentation about Central New York without going back to the first peoples. So the indigenous peoples were the Haudenosaunee, people building a longhouse. I can talk about that at great length, but I'm just here going to recognize that we're in the homeland of the Haudenosaunee. And it was, the Haudenosaunee were the residents of this part of upstate New York until after the Revolutionary War. And in the Revolutionary War, the young country actually took the lands of the Haudenosaunee and used them as payment to soldiers in the Revolutionary War. So the first non-native citizens from the whole area west of Albany all the way to Buffalo came into upstate New York because the land was available as payment to Revolutionary War soldiers. But if we go back to the deepest roots, the great teachings of the native peoples of the region are that in every deliberation, the leaders must consider the impact of their decisions on the next 7 generations. When I first heard this years ago, I thought, gee, 7 generations, how long is a generation? I wanted to know, like, so how long do I have to think ahead into the future? How long is 7 generations? And later, when I first met Chief Warren Lyons, that was like this burning question. So how long is 7 generations? And he's like, oh, grasshopper. I learned from Chief Lyons, it's not an equation. It's not meant to be taken literally. But if you take it literally, if you're an engineer and you want to write an equation, you say, well, a generation is 30 years. So first non-native peoples came to central New York around 1780. And if a generation is 30 years, 7 generations means we are currently, right now, literally the 7th generation that is in central New York. And this outline of the 7 generations of non-native peoples in central New York serves as the outline for what I'll present. I'll talk briefly about the Erie Canal. Note that the city of Syracuse incorporated in 1848, Syracuse University founded in 1870, and then in weaving into our story of HVAC, the American Society of Mechanical Engineers was founded in 1880, the American Society of Heating and Ventilating Engineers in 1894, the L.C. Smith College of Engineering of Applied Science was established at Syracuse University in 1901, Willis Carrier invented air conditioning while working for a firm in Buffalo in 1902. Carrier Corporation relocated to Syracuse in 1937. There's a typo there. It should say UTC acquires Carrier. There's no SU on that line. UTC acquires Carrier in 1979. U.S. Green Building Council started in 1993 in Syracuse COE in 2002, and we'll weave all that together in the story of from Gere's Lock to Carrier Circle. So the great transformational thing in this region and across the state and really the country was the construction of the Erie Canal. The first Erie Canal opened in 1825, and that led to a transformation of the state and the country and even the world. One of the first people to come to the Syracuse area were 3 brothers, William Stanton Gere and his brothers Robert and Charles, who moved to central New York in 1816. And like serendipitously, they got land in a place that the Erie Canal went through. And in fact, that place became known as Gere's Lock. And actually, if you drive, it's just west of the state fairgrounds. There's an exit there on 695 that says Gere Lock Road. That's Gere's Lock. And so William Stanton Gere had a son named James Monroe Gere, and he had a son named James Brewster Gere, and he had a son named William Anson Gere, who graduated from Syracuse University with a degree in civil engineering in 1884. And he had a son named William Stanton Gere, who graduated from SU with a degree in engineering in 1917. And William Stanton Gere, one of the 3 founders of the firm Holmes, O'Brien and Gere, which now is known as O'Brien and Gere. So companies that are critical to actually HVAC in the region and the economy of the local economy are tied right back to the first non-native peoples who settled in the region and who were active important in the development of the Erie Canal as a corridor of commerce. So this is one of my favorite images of Syracuse, bird's eye view of Syracuse in 1874. So in 1874, Syracuse was the 29th largest city in the United States. So it had gone from 0 in 1800. Really, in 1780, there was no Syracuse here. Erie Canal opens, and actually, Erie Canal is that waterway that's running from the top of the image to the bottom of the image. It's bird's eye view. So the bird is flying over the western part of the city of Syracuse, looking east. That waterway that's going diagonally from the center toward the bottom left, that's the Oswego Canal that's going north to Lake Ontario. So the city of Syracuse was born as a port at the intersection of two waterways. And then those waterways were there for 100 years. And then kind of interestingly, as a case study, imagine like Pittsburgh, born at the intersection of three waterways. And then, 100 years later, the water goes away, right? So that's the story of the city of Syracuse. So the Waylock building is there, was the toll booth at the intersection of the Erie and Oswego canals. In Clinton Square was a great place of the canal coming through the center of town. The Armory was there in 1870, and this is 1874, and the Hall of Languages, one building of Syracuse University. So Syracuse University started in 1870. It's one building, the Hall of Languages, and that's the city of Syracuse in 1874. And this at the time, the city was a hotbed of innovation in precision manufacturing. And one of the key people is this fellow, John Edson Sweet, who was born in 1834 in Pompey. His grandfather came to the region because he was a Revolutionary War soldier and was paid in land. Sweet Road, which runs, that's the Sweets of the Sweet Road. So John Edson Sweet's initial training was as an architect. His brother was a surveyor. His brother published a famous atlas of Onondaga County. John Edson Sweet's 19 years old. He designs a church that is still standing today. It's the Orange Church on the road to Cazenovia. You look at above the doorway there, you can't read this in the back, but it's the Pleasantville Society Free Church, erected September 14th, 1851, J.E. Sweet architect. So 19 years old, this is like good work. He's recognized nationally for his architecture, and he was doing architecture in Alabama when the Civil War broke out, and he decided that he wanted to come back home, and he became a pioneering mechanical engineer here based in Syracuse, and he is credited with being the founder of the American Society of Mechanical Engineers. On the left of this slide, you can possibly read it. It's the first page of 5 pages of an obituary that's published in the ASME Journal in June 1916. And it's a spectacular piece about Sweet. I'm just going to read this one paragraph over on the right. Dr. Sweet's prominence as a national figure dates from his connection. He was a faculty member for 6.5 years at Cornell, beginning in 1873. It was a case of the man and the hour. Mechanical engineering as a department of organized education was a new thing. In it, there were no precedents, and regarding it, there was almost universal skepticism. Its plans, its scope, and its aims were unformed even among its friends, and its friends were few. The field was fallow, and into it came almost by accident the personality of this untried and unknown man. So this is an aerial picture I'm going to show later. That building, this is in the foreground, in the road that's running horizontally there through the image is South Geddes Street in Syracuse. The building on the corner there is John Edson Sweet's factory of the straight line engine shop. And actually, he was an architect first, so he designed this sawtooth roof for natural lighting, and that was copied around the world. But that was John Edson Sweet's shop, and it was right next to a shop known as Leip's Machine Shop, out of which dozens of companies in Syracuse emerged. So this building is known as the cradle of Syracuse Industries. There's a terrific on Wikipedia. There's an amazing list of all of the collaborators that worked in that shop. And it's still standing today. You go to South Geddes Street, the hardware store was Leip's Machine Shop, And it was in that hardware store that one of the collaborators was somebody named Alexander T. Brown, who was born in Scott, which is in Cortland County, and his grandfather was a Revolutionary War soldier. Came to work with a gun manufacturer in Syracuse, worked in the Light machine shop, and then together with Light, they invented the bicycle gear. No kidding, the bicycle gear, to change gears on bicycles. Somebody had to do it, and this comes from Syracuse. So right there on the hardware store is this great mural of Syracuse, New York, hub of the bicycle world. The truth. This is like literally the hub. So it was Alexander Brown, and again, precision manufacturing, this key strength of the region that was making small parts moving. In around 1880, there was this innovation that came from France, the typewriter. So Alexander Brown and L.C. Smith saw the typewriter at a trade show in Philadelphia, and they say, gee, we can make that. So they start making the typewriter. They had a factory on the near west side on Gifford Street, and then they needed and then actually L.C. Smith came to Syracuse University and said, what will it take for Syracuse University to start a program in mechanical engineering? I like to think, he said, my company needs mechanical engineers. Would you please make some? So the deal was $75,000 in 1901. Smith Hall. So that's what $75,000 in 1901 looks like. And then he needed a bigger factory, and they built a bigger factory at the intersection of East Washington Street and Almond Street on this site. So we're on the site where Smith Corona built typewriters alongside the Erie Canal beginning in 1902. Smith, an enterprising business person, looked and saw the West Coast was developing, and he wanted to put a stake in the ground in an up-and-coming city, which at the time was smaller than Syracuse, Seattle. Go to Seattle, see the Smith Tower, that's from L.C. Smith. And that was, L.C. Smith, typewriter manufacturer, Seattle, here it is, Syracuse. So now I'm going to switch to, we talked about ASME, John Edson Sweet, founder of ASME. So you got the founder of ASME is in your community, and he's like infecting other people. There should be like professional societies of engineers in different areas. So in 1894, a predecessor of ASHRAE, the American Society of Heating, Ventilating Engineers starts. And first president, Edward Bates from Syracuse. And then later, 1904, the American Society of Refrigerating Engineers. And then in 1959, those two organizations merge and create ASHRAE. So again, now back to that neighborhood on the west, just west of downtown. 114 Merriman Avenue, that's the house that's there today. That was the home of John Edson Sweet. On October 5th, 1903, this is John Edson Sweet's notebook. It's like an engineer, right? Page number 1. Minutes of a meeting of a volunteer general committee which met at the home of Professor John E. Sweet, number 114 Merriman Avenue, for the purpose of making plans for the creation of a professional and social organization among the engineers of Syracuse. The following named, they're all guys, gentlemen were present, and there's a list. And there's a list, in the list is Dean William Kent. Who's Dean William Kent? Well, it's the William Kent of Kent's Mechanical Engineers Handbook. It's the first dean of engineering at Syracuse. Syracuse just started its College of Engineering. They go out and they hire an eminent mechanical engineer to be the dean of engineering. And actually, so Kent comes, and also he serves as president of ASHVE in 1905. So one of the things about this story is HVAC was present in central New York before Carrier came here, right? So Bates, William Kent, others, in fact, lots more to tell, but that's a diversion. So now back to this neighborhood.
By the way, you didn't say it, but the organization you're talking about is the Technology Alliance of Central New York.
This is that meeting, that founding meeting. I mean, this is not when we gave the 100th anniversary lecture. I mean, this is like that's what we're talking about.
By the way, I have that notebook.
Oh my gosh! I should have asked you to bring it. So now back to this neighborhood, and we're next to the light machine shop. So on that site was a huge factory, the Franklin Automobile Works. So this was the original Franklin car, and then later this was a high-end Franklin car, and then that's this aerial picture of that facility. And if you go to the site now and you read the historical marker, there's on the front side that you see from the road, it talks about the Franklin Automobile. You have to go around the back, and there's a list of milestones. The milestones are just like, 1919 winner of the Los Angeles to Yosemite economy run, 28.8 miles per gallon. 20s, largest employer in Syracuse, more than 5,000 jobs, Franklin Automobile. Whole side of the city is employed at Franklin or its suppliers. Depression, high-end car, Franklin goes out of business 1934. Devastating in the community of Syracuse. Community comes together, raises $250,000 during the Depression, and goes to recruit someone to come and fill the vacant Franklin plant. So who do they get? Carrier. Carrier comes to Syracuse in 1937 into the vacant Franklin Automobile factory, hiring the idled workforce, $250,000 incentive, consolidated 5 plants from New York and from New Jersey and Pennsylvania. These are things that Carrier's doing at the time. So now I want to talk about Willis Carrier. And I'm going to have to pick up the speed because I promised Bill he's going to get the floor at 4 o'clock. Oh, he's giving me 5. He's yielding 5 minutes of his time. Anyway, here we go. Willis Carrier, born in Angola, New York. So that's a thruway stop. It's west of Buffalo. It's that crazy stop that's in the middle of the thruway that you park on either side. So that's Willis Carrier's hometown. His great-great-great-great-grandfather came from England in 1663. Mayflower was 1620, right? So this is one of the first peoples coming from Europe. And actually, his great-great-great-great-great-grandmother was burned at the stake in the Salem witch trials. True story. His great-grandparents left that part of New England, and they settled in Sherburne, New York, in Madison County in 1799. And then his grandparents moved to Angola in 1836. And there's no way to figure this out, but it's got to be on the Erie Canal. They had to. It just had to. If you're going to Buffalo and you're coming from Sherburne, you're getting on a boat in the Erie Canal. Goes to Cornell, gets a degree in electrical engineering. 1901, electricity is, oh my gosh. He's from Buffalo. Buffalo's the city of light. You're going to Cornell, you're studying electrical engineering, you're going back home, he wants to work for GE. Instead, he goes to work for a company called Buffalo Forge. Buffalo Forge makes things for forges, for blacksmiths, and actually, so electricity, electric motors, ventilation. So they're making fans for factories. Invents air conditioning. I'll talk a little more about that. July 1902. Buffalo Forge, a great strategic decision, says, this air conditioning thing, it's not going anywhere. 1914, we're making, things for factories. So Carrier and 6 other people leave, and they start the Carrier Engineering Corporation. They open up a manufacturing plant in Newark, New Jersey. First centrifugal chiller they made in 1922. Their customer, Syracuse, China. Onondaga Pottery in Syracuse. The first centrifugal chiller comes here and installed in Syracuse. Carrier served as president of the Refrigeration Society in 1927 and president of ASHV in 1931, and was one of the people that brought the two together to make ASHRAE. There's this great little book, Willis Carrier, Father of Air Conditioning, written by an early engineer of Carrier, kind of lovingly documenting everything. So here's, the chapter. He goes, Willis Carrier went to work for Buffalo Forge Company July 1, 1901. His first work with the drafting board involved a heating plant for the Erie City Boiler Company. Subsequently, he worked on a system for air drying lumber, another for drying coffee, and a third for which involved forced draft for boilers. By the time Carrier had finished these first assignments, he realized that available data were insufficient to design soundly engineered heating, drying, and forced draft systems. So then subsequently there's this assignment. It's about controlling humidity at a printing plant in Brooklyn. And it was that assignment that led to he's recognized as being the father of air conditioning. And then in italics here, these are Carrier's words, the definition. Air conditioning is the control of humidity of air by either increasing or decreasing its moisture content. Added to the control of humidity or the control of temperature by either heating or cooling the air, the purification of the air by washing or filtering the air, and the control of air motion and ventilation. We're still doing that today, right? I mean, that's that's the father is saying, like, this is what air conditioning is. This is what we have to do. We have to do all these things. Temperature, it's humidity control, purification of the air, control air motion and ventilation. There's this great passage in the book where one of his salespeople goes out and talks to somebody that's building a high-rise in New York City. The inquiry convinced me that soon there would be a market for air conditioning in tall buildings, and I had better design such a system. Edible fish were in sight, so I started fishing. In 1928, while air conditioning the company's own offices in Newark, Carrier designed a system which served as an experimental one for other office installations. This is going to get the Bill's presentation, right? So Carrier's own headquarters was a test bed for a new technology. 1928. 1930, they made their first sale. 23 installations by 1934. We have in the display case out here on the second floor and here in my hand this terrific artifact of the past from the Carrier Engineering Corporation. So you open this up on the inside front cover, the Carrier Weathermaster, a series of photos and drawings showing the details of construction and installation of the Weathermaster, a Carrier development for the admission and distribution of conditioned air to individual offices or rooms. And so this is the sales book for somebody going out to say, this is how it works. And there are these illustrations. And actually, if we go to Link Hall, we can see this system. Like, this is the infrastructure of the Carrier system. So this is the original Weathermaster, chilled water, steam, and forced air. So ventilation, here's the chiller, there's the air handler. And now, since I'm still focused on 405. I want to do this little detour. Again, it's like a time stamp in time. So Carrier's in Newark. He's doing this thing. My father graduated from high school in June 1938 in Paterson, New Jersey. Paterson's not far from Newark. So this is his high school yearbook. It's the Senior Mirror, Eastside High School in Paterson. So here are the pictures of the seniors and their aspirations to be a doctor or a teacher. And here's this guy, my father, and his aspiration is to become connected with the air conditioning industry. So this is a high school senior saying this is like the most exciting thing that could possibly happen, is like air conditioning is changing the world. So the short story is he did, and I followed in his footsteps, and I'm in Syracuse. One of the reasons is because of proximity to Carrier. So back now to the Franklin Automobile plant. So this is the site that Carrier came and filled that factory. And then back to the story of Carrier. This is Carrier's own words, writing, when we remodeled the Franklin office building, we installed our experimental apparatus, yet untested. So it's a next generation air conditioning system. History repeated itself. The first type of Weathermaster grew from experimental equipment we tried out in our newly acquired office building in 1928. The second from our experimental setup installed in the building we acquired in 1937. So Now really fast to the finish line. Carriers in the city on South Geddes Street, World War II. After World War II, there was a plant that was built to make aircraft engines. That plant was auctioned. There were two bidders, Carrier and Syracuse University, and the property was split. Carrier got half, Syracuse University got half. Syracuse University moved its College of Engineering to that campus in 1948. And now I'm going to flip ahead here. Carrier's influence coming to today. In 1993, there was a guy named David Gottfried who had an idea for establishing what became the U.S. Green Building Council. He teamed with a friend named Mike Italiano. And together they went around and they pitched the idea for the U.S. Green Building Council to companies. And the first company to sign up and say that they would be part of it was Carrier. And actually the person who made the commitment was Rick Fedrisi. And that's a picture of Rick Fedrisi from 2001. It must be like his college picture. Native of, we all know Rick, native of Central New York, bachelor's degree in accounting from Lemoyne, MBA from Syracuse, went to work for Syracuse, went to work for Carrier, became director of communications and environmental affairs, and was critical in the founding of USGBC and its subsequent leadership. And now I want to come to Syracuse COE and actually then tee it up for Bill. So Syracuse COE emerged from a combination of a regional economic development plan called Vision 2010 and also a strategic plan that was developed in the College of Engineering and Computer Science. The intersection of those two, there was a meeting in 1998 at the offices of O'Brien and Gere. The meeting was chaired by Neil Murphy, who at the time was president of O'Brien and Gere, and I was dean of engineering, and I was brought in to facilitate the meeting. And at that meeting, somebody from Carrier stood up, and I don't remember who it was, but it wasn't Rick Fedrisi, and said, it was a moment like from the movie The Graduate. The guy from Carrier stands up and says, green buildings. And I'm like, green buildings? What's a green building? Tells us what green buildings are, talks about indoor environmental quality. Everybody in the room got it. We're like, that sounds great. We should do that. We're going to collaborate around developing innovations for this new thing called green buildings. Back to the College of Engineering and Computer Science, we had committed to hire faculty members in areas aligned with regional strengths. We hired Professor Jensen Zhang, who's here right now. He's the first faculty member. He came in 1999. He was our first faculty member to move into this area, and Jensen's led the development of research and teaching here. Later, companies came together, founded the New York Indoor Environmental Quality Center, and then later we won an award called the Star Center, and we hired Professor Ez Khalifa. Just as a word of introduction for Bill and his presentation, Bill wasn't at this initial meeting, but Bill was working for a company called Ropes and Woes, and the CEO of Ropes and Woes was there. And when we said, who wants to work on the green buildings? Actually, the guy from Ropes and Woes put up his hand faster than the guy from Carrier. So it's like, okay, so Ropes and Woes and Carrier, you're going to work on this together. So Bill Pisano goes back to the office and says, hey, Bill, I just signed you up for this thing. So Bill was involved in what became the COE from day two, and really in the design of this facility and really all of our programs. So we salute Bill's leadership in Syracuse and your lasting contributions. So we were established in 2002 as a state center of excellence. Now looping back here to L.C. Smith, again, on this site was his factory. That factory was demolished in 1999. On this site, we built this facility, and part of the facility on the 5th floor, involves this world-class, the best in the world facility for testing human subjects and the impact to indoor environmental quality, the Willis H. Carrier Total Indoor Environmental Quality Lab, and that facility has been used for pioneering research that is changing the world's understanding of how people respond to indoor environments. So you already know, and you've heard in this series of R&T forums, presentation by this team led by Joe Allen from Harvard, collaborators Usha Satish from Upstate Medical University, Suresh Santanam, who's here right in in the fourth row over here, John Spengler, who studied how indoor air quality affects cognitive function of office workers in a simulated office environment using the capabilities of our facility. And without going into the details, because actually they've been presented here before, I'll just say this is the key slide that shows relative performance across 9 different areas of activity. And the bottom line is there's a bottom line. John Mandak says, fresh air makes you smarter. So if you double ventilation rates, the performance, the decision-making performance of office workers increases by an 8 percentile increase. And that has a value of $6,500 a year in performance of office workers. So when we envisioned this building, this is what we envisioned. Quantifying the benefits of better indoor environmental quality through innovations that would provide it. And it was, again, I'd say, again, this is like a legacy of Carrier in the region, and hopefully this positions us for hearing Bill talk about UTC's Center for Intelligent Buildings and leading us into the future. And without further ado, it's 4:06 and 40 seconds. I'm going to turn the floor over to our friend and collaborator and really terrific inspirational leader, Bill Chapter.
First thing I got to do is get to my presentation. Good. Always the front row. There's nobody sitting in the front row here. Thank you all for coming. I don't know what I'm going to talk about in 3 years, but maybe we'll have another building to talk about. This one, very similar to what we did at the Sistine Chapel, day one to when it was done, 4 years, same thing here. October of 2010, about 2 weeks after we dedicated the Sistine Chapel, I started working on this building. Did I get that right? 2014 to now, 2018. And we've been in the building a short period of time. I'm going to go over what the building is. I'm going to be working with a presentation that is set up from a marketing standpoint. I'm not allowed to just ad lib on all this stuff, but I will a little bit here and there because I got involved in way too many details and way too many meetings. So if I hit a tangent, raise your hand and say back on track. And also, if there's any burning questions that come up, raise your hand. We can talk about them at that time. There will be time at the end to do questions, and if there's an interest, I'll log on live to the building on the building automation system, and we can actually explore the building together a little bit and see what it's doing right now and let you take a look at the HVAC side more than anything, because that's really where I'm coming from. What you're seeing up there is revolutionizing the future of smart buildings. We're calling it the Center for Intelligent Buildings. A lot of times people interchange those words. I'd like to differentiate them. Intelligence is the ability to understand something. Smartness is the ability to practically apply that intelligence. Hopefully, we've done that in this building, and I'm going to see if we can get around and talk about it in some detail. If you had seen this slide a month ago, it would have said UTC up there. I'll tell you right now, we're spun off. We're in the process of becoming an independent corporation again, but we still think of ourselves as part of the UTC family. Climate control and security still exist, so all the brands that you see at the bottom are still part of what you get when you come to us, whatever you want to call us, doesn't matter. There is the building itself. It's sitting prominently along Interstate 95. So if you want to take a long drive, you can do that, or you can fly down to Palm Beach International and take a short drive. The building itself has 2 towers. North tower that runs parallel to intersecting road. South tower cocked off at a little angle. Love the architects. Everything's a little bit different. Do we have architects in the audience here? Okay, I'll try to be nice. If I'm not, let me know. How many consulting engineers or engineering people in their background? Okay, so we have a few there, so don't embarrass me too much. The building is curved on the south side. It is solar shaded. You'll see in other pictures. We have a large 4-story atrium that connects the two towers. There'll be images of that as we go through. I was going to show the video, but we've logged on too many things simultaneously. The invitation to this presentation has a link to a short promotional video. If you didn't see it, go back, look at your invitation, and check it out again. You'll get a direct feel from the senior management. It'll help put this whole building together, what it means to us, what we're going to be doing with it. And I can tell you already, less than a year, we've had over 14,000 visitors to this building. So we are spending our change and then some, bringing people in to see what we've done and trying to see if we might market similar concepts for similar buildings. A simple question: where's the value? What group do you think would enjoy the most the benefits of a smart building? I could say all of them. I could say one or two of them. And I think it's going to really depend on your view of what a smart building is all about. We're going to try to talk about that a little bit. From our own perspective and what we're doing with this building, and it is for us, we've got upwards to 500 people that are going to be in this building. So we've concentrated an awful lot of senior staff in the building. So senior management has an idea about what this is going to do for the functionality of their staff. Open and collaborative building. If you were to go on the upper 3 floors, those are the staff floors. The 2 lower floors are more of the public display floors in the building. I have lots of pictures of those. I don't have any pictures of the upper staff floors because they weren't occupied when this thing came together. We moved into the building before it was done. So commissioning lasted about 4 months while it was being occupied. So it's not the right way to do it. But when you're a year and a half behind schedule on opening the door, eventually the moving truck shows up, whether you're done or not. So the upper floors are very modern in a sense of, like right now in this space, if you were to imagine 2 long desk rows face to face, your area that you get to work in is about 4.5 feet wide, deep enough to mount 2 large monitors. You've got 1 side file, and that entire desk will go up and down. You can stand, you can sit, you can do what you want. Somebody can walk by. There's a cushion on top of the side file. You can sit and have little impromptu meetings. There's little areas that you can go and congregate. There's little rooms that you can schedule. The older people in the building are like, what is this? The younger people in the building love it. And so I think it's a process of evolution, and unfortunately, we've never really ended or landed in one place that we really like. So this is an experiment in progress. We've also done a building down in Brooklyn where we've taken mostly millennial and younger people and really crammed them into that building, and I hear everybody likes it because they're all right next to each other and they're all plugged in and nothing is really bothering anybody. And if you need a private meeting, you go into one of the huddle rooms or the small conference rooms and you have a private meeting. We have, as you would expect, put in the extra ventilation, so we are indicating that we're going to get that cognitive function benefit. We are working on LEED Platinum. Another slide will say targeting. We've still got a post-occupancy item to confirm that we achieved it. Once we do that, then this will be absolutely true. The occupants in the building, I think, are getting used to it, loving it or not, but it's very digital, very technically enabled. And the security people who worked on this building from day one, along with the IT people, were part and parcel of the backbone of the creation of the building. Very critical, very important. You can't add it in at the end. It's got to be part of the design process from the very beginning. I'll comment on that a little bit as we go through. Out of this slide and these questions, think about us selling the concept to people, talking to them about, what is the real value. We feel the first three items are of significant value to us because if the building does not operate efficiently and it costs too much to operate, it's going to be on the why did we do that, let's not do that on the next building. So a lot of effort was made in that first item. If we are able to enhance the workers' experience in the building, the people that we're paying a very high salary to, that we're looking for good strategic decisions, for smarter thinking, and we lose them, the cost of recruiting somebody is usually a major portion of their first year's salary. And then you train them, and then you lose them. Guess who? You trained them for somebody else at our cost. So we very much want to bring in the right people and keep them there. And the building is very open. I typically wear a badge. You don't have to wear a badge. Your credentials are on your phone if you're assigned to that building. A lot of things are assigned to your phone. We'll talk about that as I go in there. And being where you saw us near major highways, a lot of traffic, a lot of activity in that part of Central Florida, there are events from hurricanes to fires to accidents, things of that nature. People could literally walk in the front door of the building. So our credential in protecting people is a very important portion of that building, and I'll show you what we call a command center that we have within it. So there's the building stats. Very state-of-the-art, about 250,000 square feet, been in it not yet a year. We should get U.S. Green Building Platinum. We were told on day one on the green charrette, this building is not going to be a science experiment. It's going to have the stuff we can sell today. Well, it has stuff in it that we're testing so that we can sell tomorrow. All the people who said this isn't going to be a science experiment have moved on. So we are doing it as a science experiment. The whomever is in the building today, name-wise, it's going to be called Carrier. Otis is in there, regional. We're not sure if they're going to stay because it's a separate corporation. Fire and security is a part of who we are, and we hope they will stay. It is still an owned building that different business units get charged rent. People don't move into the building for free. So keeping not only your employees, but if you will, your subtenants. I don't know, did Pete King come here? Is he here? Yeah. Okay, because I saw him on the list. When we put the green charrette together for their new building over on West Street, they planned on occupying the whole building. Well, they don't. They have sublet part of the building. So anything you do with the building, think about the future with you and potential other tenants in mind. A building is very much a living, breathing thing. So from the inside, you walk in the atrium, you're going to come in this front door if you choose to come in the main entrance, and there'll be a guard, and he'll talk to you, and you'll be pre-credentialed. We are interested in knowing who is coming to the building, and we set up a set of credentials ahead of time, so when they come, they can have that same freedom to move around the building. 4 stories of electrochromic glass that changes opacity depending on the time of the solar vision, if you will. And this is, unfortunately, a direct east view. So if you're there an hour after sunrise, it's pointing right straight into the building. And those windows Here you can see through them. If you were in that building, in that atrium, in that early morning sunrise, they'd be almost black. Later in the day, they'd lighten right back up again. So we're trying to bring in the maximum amount of daylighting, and there's been a lot of very positive response to that. There's a lot of good views, a lot of good windows, but we want to limit the amount of solar gain. The escalators, you see a side view. This is all visible with windows and glass and neon lights, and you can watch the escalator working, or you can use it. And a lot of effort was made to put stairwells in and try to encourage people to walk from floor to floor. We also have 5 elevator hoistways in the building, testing a few things for Otis. I don't think I have detailed slides. There will be something later on, but if you go over to a bank, let me see, I'll start. You walk in from the garage. If you parked in the garage, you would have come in this back area, would have gone by the command center, which we'll talk about in a minute. But if you read the view when you went through the turnstile with your phone, it would tell you, oh, I know you're in the South Tower, but that's where your office is. You should go to elevator number 1. Or you're seeing somebody that's in the North Tower, it'll point you to go across the atrium to elevator bank 3 or 4. And when you get over there, push your floor. It says a cab's coming down, and you walk into the elevator. There's no buttons. It will take you to the floor you requested. If you changed your mind, you got to get off and put a different request in. But essentially, it has learned who wants. Let's say 5 people come up. 2 want floor 2, 3 want floor 4. The door opens up, and you know automatically that elevator is going to go to those 2 floors. It'll stop at each floor. Please get off, or you go to the next floor. I'm still trying to get used to it because I'm so used to pushing buttons. And I think that's part of what this building is going to be about, testing human response to changes in areas that we've been more familiar with over a long period of time. And I think the elevators is one of them. We have a large conference center. This can be broken up into 4 or 5 different settings, small rooms to large. Anytime we do our corporate town halls from senior management, they're all filmed here and broadcast worldwide. We bring people up to the 2nd floor, North Tower, almost the entire depth of that tower level, and show them all the products, many of which are operating dynamically, many of which are at almost like you went down to the Most, or you went to Disney, you went to places, a lot of interactive displays. These will change as the product lines change. This is not a display. That is the chiller room and a highly polished epoxy floor that you could eat off of with enough room to bring 20 or 30 people in to take a look at the equipment, all color-coded. I never had that good a chiller room in any building I did. We had barely enough space in this building to get 2 people in front of some of the equipment. And so it's not easy to see this amount of room, but again, if the chillers are the old model and we want to change them out, we can easily change them out, bring in new equipment. We have temporary hookups in the back of the area where we can bring additional equipment in and demonstrate how it performs relative to controlling, energy-wise or response to emergencies or anything like that. So the building is trying to be set up useful for all the different divisions of CCS Carrier that want to use the building. We're trying to be intelligent. I'm not going to dive into a lot of this because it's things you know about, but we're trying to do advanced controls. The building is fully LED lighting. We even talked about every single fixture having a URL and addressable. That went got beat out fairly early, unfortunately, but we're not addressing each single one. Lots of building energy management. We can look at this live. We can take a look at the heat maps and see who's warm, who's cold. I don't know what the weather is in Palm Beach Gardens right now, but my guess is we're still doing air conditioning or close to it. This is the equipment for the elevators and the monitoring. Lots of alarming involved. There's your phone. And we'll get into a little bit more on what you can do with your phone, but it's quite interesting. I'll save that till later. This is a slide very similar to what Ed had shown earlier on the cognitive function. We're trying to make this a building that when you're in it, it's responsive to what you want, and it makes available to you the resources that you can schedule, so on and so forth. I don't want to preclude something I'm going to say later, so I'll save it till we get to that experience. We had to tie everything together. There's all the companies. And just about every product imaginable is in this building. We tie the operational efficiency solutions and the enhanced experience solutions usually through our building automation system, which is automated logic and web control as the platform. On the fire and security, protecting people and property, we're using the OnGuard platform. We were trying to come up with what's called a data integration platform. If you were to look at the history of all these companies and you say, security reason, door such and such has got an alarm. Well, Interlogic or Edwards on a fire, they're going to call a door something different than web control is going to call a door different than somebody else. And so it's almost like the Tower of Babel. We could not find a consultant experienced at tying all these platforms together. The group that I'm in perform the function. I didn't, it's not in my background, but we have integrated these in, and we are now becoming an expert in doing this, and we're looking forward to doing it more often in other than our buildings, hopefully in other people's buildings. And over time, all the platforms that you want to be performing functions within a building, the ability to be integrated, the ability to talk the same language is going to be someday a plug-and-play situation. But it's hard to say. I mean, BACnet allowed us to talk certain things on HVAC, but all these other platforms are so quite different. Yes?
Quick question. So I was actually going to ask about BACnet, if that's what you use, but you just said that that's only covers part of the spectrum. So
BACnet's usually the building automation portion that's on web control.
But might not necessarily have anything to do with security here.
Correct.
So how do you have like a, is this like your IT department has a server somewhere and you guys are writing interfaces for these things, or?
We have allowed for this building server per platform for the integrity of the platform.
Okay.
And we've written integration language for transferable data that needs to go back and forth.
Okay, so that was kind of my question where I was getting at, is that does each different platform have a specific different interface to every other platform, or is there what like BACnet would potentially be? Is there one central?
We have created a central one for this building.
All right, that's all I got.
And we're trying very much to interest other partners and other people in purchasing it. It's not a saleable product at the moment. It's a saleable service or expertise. And it's in its infancy. It's really kind of a beta testing that we're doing on this building. And we're finding different people have different interests. And it's you, yes.
Yeah, Bill, so at Penn State, it was called the middleware project that UTC had been involved with. Mm-hmm. Was that kind of the precursor to some of this? Or?
I believe so, but I don't know if that middleware project stayed in a silo, an HVAC silo, or did it try to go across?
Well, it was always trying to be something wider. So.
Yeah, and the wider you go,
harder.
You ain't good. And my security and fire platforms are mimicked 10 times over by other people's, and their languages are different. And so the fact that I can integrate my platforms doesn't mean I can integrate the majority of the other fire and security platforms. So it's an odd market to be in. A lot of energy efficiency numbers. These are savings projected based on a typical building, designed to code. I would like to point out we did put some solar in, and you'll see it a little bit in the picture and when we go onto the web control. We've tried to do everything feasible to lower the energy footprint, the water footprint, and everything. You know, I think we started out having, what did we end up with? Almost 90 some credits towards LEED Platinum, and when we finally made our application, we had 1 extra credit. So we had to get every single one of them -1. And so it's really tough, not just on a cost basis, it's tough on a design criteria basis. I'll come back in a year. I think we've pretty much fully commissioned the building. We'll see where we stand on these projections. We're already working on what we said we'd do, what our investment was, are we getting our return on it? So we're trying to do an internal ROI on our own building. It's not fun. It's not easy. So we do everything. I think I've pretty much touched on all these, except there you can see in the picture about 40% of the roof is solar shaded, similar to what King & King did with the awnings downtown, so you can park underneath it and get out of the direct sun. We're feeding that power in to satisfy the chiller. We're using it internally. We could have put more up, but we put this up basically to buy a LEED credit we needed. We are in a situation where we occasionally do net metering and we freewheel some power back to Florida Power and Light, but we're not really doing dynamic demand response and demand limiting at this point. Nobody in the building wants to give up their share of the power usage to be part of it. I see you smiling, Hugh. Most customers said, let the other guy curtail the power, not me. So I'll jump quickly through the HVAC and show you a little bit more about the building and some of the unique things we did. Real simple design objectives: comfortable, energy efficient, want to maximize what we can do to get LEED credits out of the HVAC, provide the ventilation associated with cognitive function, but if the number of people are less, can we reduce the ventilation and still keep the 40 CFM per person? Do we know where the people are? Do we have the ability to send the ventilation to them versus just in general? All questions, answers forthcoming. We're still learning how to run the building in the level of detail that's needed to really finesse it, but we put it together in a way that hopefully would be able to do that. I'm going to show you primary products. This is the first floor plan of the building, and down here you'll see it color-coded shortly. We're using standard air handling equipment, VAV boxes. These are large zones. This is the conference center. This is a big cafeteria, a big kitchen in the middle. A lot of air movement in this area. And so traditional. We were going to even put some rooftop units in. That got VE'd out, but we were going to air condition the chiller room with a rooftop unit above it. I said, why not a fan coil and chilled water? It's right here. Well, I'm trying to demonstrate product. And so the gentleman who had the rooftops, he said, 250-ton rooftops on each tower would be all done. That didn't win over. Nobody wanted to do that. So some typical equipment on this floor. This is showing the second floor in this picture right here. This is the big customer area that we were talking about, where people come in and can see all the products. Ed, if you ever get down there, you want to go here because we have the story behind all Sikorsky, Otis, all the people are there. We've got another version of Carrier's psychometric cylindrical ruler and all that. So our heritage is on display at the building. And we're getting into some of the private spaces here. So you see VAVs, fan coils, a little bit of VRF. Not a lot of it because the building's too big. We were trying to find selected areas. Originally, we were going to do for the upper management floor dual system. We were going to put them on the main system and give them a backup on VRF in case the chiller crapped out or something. They could have their floor cooled with a VRF system, but that got pulled out as well. And induction beams. The Weathermaster stuff that you were showing, I think was the origin of the sidewall high tower induction unit, which we stopped making. Carrier stopped making that probably in the 50s, except for replacement units, which we still sell about 1 million a year. So there's a lot of buildings that still have them in it. And thanks to the folks over at New Climate, they said, hey, we can do it up in the ceiling, and they developed this product, and we OEM it through them. And the staff floors, we've got about 400 induction terminals on all the staff floors. We're getting the required 40 CFM per person, probably more when you look at a diversified number, because any day at work, never is everybody there. And I would say the diversity on this building is proving out to be as low as maybe 0.7. So 30% of the people that have assigned desks or rooms do not come into work. Not that they're gone all the time, but on any given day, there's about 30% of the people missing. We don't reduce the ventilation because the induction units need it to function. There's a limited range at which they will properly function and still give you cooling. They'll give you ventilating at a low flow, but you won't get the cooling out of them. So at this point, we've had really no ventilation complaints in this building unless we're pulling in something from the make-up air DOAS units on the roof and then distributing it around the building. So we've been very fortunate in that regard. This shows you the base floor, and it shows you, I believe there's about 9 different systems, plus unconditioned, which, you know, a few spaces get only heating, no ventilating. I had a series of these, probably 5 or 6 of these as you work your way up the building. I had to sell it to the top management, what we were going to do in the building. And the guy who was running the Carrier group out of everything said, nobody puts all these things in one building. Why are we doing this? And it's because we're trying to sell all these things, and we wanted to show people that they function properly and you can get a viable solution many, many different ways. I'm not showing the right floor here, but if you went up above, let's see, I can just back up one. This is wide open. It's being conditioned by 3 different systems simultaneously, all on the same set point. You can walk from one end to the other and not notice a difference. And we did that on purpose to say, pick the solution that works for your building, you'll be happy. Pick the wrong one, maybe you won't be happy. So things quieted down. We still have at least 6 different systems that can be demonstrated in the building and can be shown. Okay, safety and security. I'll walk through about 10 minutes and then we'll have some time for questions, or we'll jump on live if everything's still good here. This arrangement is 24/7. Your typical 5 or 6 screens. There'll be a security guard there. It's on public display. It's showing how we watch the performance of the building internally and what you can do with it. Typically, this is in a facility manager's office somewhere in the back, and little alerts pop up and the screen of importance pops up. we're trying to demonstrate quite a bit here. We had, during the construction of the building, a majority of the people who moved into it were further west, more into the swamp area of past Florida Turnpike and over by Lake Okeechobee at our Pratt and Whitney plant. And there was a big fire, and everybody knew it because the DOAS unit brought the smoke and distributed it all around the building. So we have a full sequence of operations associated with an event. We have a security response that the system will do manually. The guard will be notified as to what was sensed. They will know what should be done, and if they agree, they will hit a button, if you will, and the BAS system will automatically either limit outdoor air intake or do just the opposite, increase it if it's a flush. If it's an internal generated contaminant, we'll go to exhaust mode. All these things are automated into the building. And we can do that because of the amount of information that we're getting associated with the building automation systems. The smartphone app, very much a part of what's going on. And I've noticed people of all different ages associated with using the building are always, doing their conference room scheduling on their smartphone app. The phone is an identifiable device. We're not putting anything in or on you, but wherever your phone goes, we do positioning and we know where that phone is. So at any one time, let's say I'm looking for Hugh and he's usually on the South Tower, second floor, I can never find him. So I can plug in and say, well, Hugh's in a meeting upstairs, or he's up on North Tower, fourth floor.
No, I just left my phone.
Yeah, no, that's exactly the situation. So if you carry your phone around, if you're comfortable using it, if you use it a lot, then A, I can find you. B, if there's an emergency and people are supposed to evacuate, the security fire response can say, hey, there's 5 devices that have not left the building over in this area, and they can go and check it and try to find out what's going on.
Are these your carrier phones or personal phones?
These are carrier phones, and I believe if you are a pre-credentialed person visiting, I don't know whether your phone will do that or not. I think we haven't gotten to the point of doing that yet.
So if I was a guest, I wouldn't necessarily.
No, right. Yeah, you would not necessarily be able to do that. There's our way of presenting the cognitive function. I'll be in a meeting on Friday down in New York City trying to convince people to do this on their new 75-story building. So hopefully. They are also interested in, can we put in gas phase filtration to purify and recirculate the internal air in the building? To a point. You can clean it, but you can't re-oxygenate it. So there's limits. So we have not been able to sell this flat out easy because people are still saying, isn't that going to cost me a lot in energy? And they just don't want to believe the productivity increase and the true life cycle value associated with the better performance of the staff or employee. So it's still got a ways to go. So I think not every one of these, if you've got a private office, you can have a profile setting for your comfort, and when you walk into the building and go through the turnstiles, if not even the garage, because you get into the garage with your phone, it will turn your lights on, it'll adjust the settings for your temperature control for your space. I don't hear people using it to call elevators. Doors that you're supposed to be able to get through that are locked, you can get through, assuming it's the right time of day and you're supposed to be in the building during that time of day. So it's very tight. The reserving conference rooms gets used a whole bunch because it seems like no matter how well planned the building is, oh, we need to bring in space for more people, let's drop one of the conference rooms.
So My Way, when I put that into the App Store, the first thing that comes up is McDonald's.
You can get My
The
Way.
second thing that comes up is, there is a My Way app for travel. So is that a commercially available app, or is that a UTC
Well,
internal?
apparently we've trademarked it. I see it up there, but I don't know how protective a TM is, and do you get it
So
your way?
is it meant to be a publicly available?
No, it's meant to be from us.
Oh, so this is UTC for.
Yep.
So if you sell the 75-story office building, that could be a product that UTC would
Absolutely.
offer.
Absolutely. And if they want to credential it and call it whatever the name of the company is, which I'm not telling you, Way,
Right.
we'll let them do that for a price. Assuming, I think, we get enough stuff to connect and do with the My Way app. All right, I need to move quickly. The one thing I want to say here, we are literally sensing the heck out of the building, and we are bringing data uploads of up to 100,000 points every 15 minutes, and we're really working hard to do advanced data analytics. Because more than anything, we don't want to bury ourselves in useless information, but we want to do smart things with that information. And so that's what we're really hoping to learn with this building. And so what we opened with will look different a year from now, 2 years from now, and hopefully will become a standard product that you can buy during that period of time. You got to do it from the beginning. You got to enter everything in there right up front. You can't add it on later. Plain and simple. All right. So I can go to this screen live, but any other immediate questions people want or want to go back and comment on before I do this? Yes, Jensen.
Yeah, thanks for a great presentation. Is the data available for education purpose? Students want to log into it, get some data.
I would say if you're interested in certain elements of the data, get in touch with me and I'll get you in touch with the right people and see if we're trending that and have it available. I think the people who run the building would say, I don't want to give up data during the commissioning process because we were not operating the building as designed. We were doing a lot of testing and troubleshooting and stuff like that, but it'd be a good time to talk about from this point going forward.
The question is, this is a very big project that from design to the implementation, how much did the building from the BIM model has been applied? Do you have like a continuous application of the BIM model from conceptual design, middle stage, and the final design, and all the way to?
Well, if you're thinking of as comprehensive as CHAMPS and programs like that, we did not do that. We allowed the consulting engineering firm to use what they typically used, and it starts around the energy model and, of course, the building design, which reflects back onto the energy model. They used IES out of the UK, and then they post-processed all the data in their own spreadsheets because they wanted to validate the results. I see Jim's here from our hourly analysis program, Jim Pegues. He and I have been talking about, can you now take the building that was modeled and feed information into it and validate the model and use it as a benchmarking tool for future adjustments and changes in the building? Sure, but it's not on the near horizon. But the ability to do it, I think, is there. It's quite an investment to do it, though. And I think most owners want to see some of the trending, want to drill down in certain areas, want to make sure that the data that's coming out is informative and actionable so that their staff are doing something more efficiently than they would have done if they had otherwise done if they didn't have that information. The more sophisticated the building, the more it needs a little TLC along the way and needs people using what the building is providing to inform their day-to-day tasks. Or people forget how to use it, forget why it was beneficial, and the next thing you know, something gets turned off, or we're not going to buy the upgrade, we're getting along fine, so on and so forth.
Talk a lot about the occupant experience. Is there a lot of surveying going on of the employees, or is it more anecdotal?
Anecdotal at this point, unfortunately.
Put that into my way.
Okay. Although actually there is an app that Cushman & Wakefield, who's our building management firm, allows every employee to put in a work order. So if there's a problem somewhere and you sense it and you see it, you can put in a work order. Now, I don't know what the response rate is. Yes, Gere.
Hi there. Joe Borowitz has a couple of questions. First, are there any plans to quantify the non-energy benefits like tenant experience, retention, or operational efficiency?
Very much so. And we're interested in having the right people in the building concur that they want to have it studied, be willing to, as Chetna was saying, be surveyed or respond to metrics that could measure that. And I've talked to the CCS staff who are responsible for the building, and they said coming next year they will start assembling those KPIs and we'll be monitoring the building in detail. Now, whether or not they'll branch quickly from the energy operational dollar value one to some of the softer occupant experience ones, we're going to just have to wait and see.
Okay, second question from Joe. What do you see as the challenges for advancing smart buildings?
Dumb owners. And truly having to inform the population who designs it, builds it, lives in it, and maintains it. It's a slow process. And every chance you've got to sort of promote a feature, remind somebody that the performance of that feature benefited them in their setting. I mean, to me, when we did LEED, that was just logical, straightforward. We should have been doing LEED from the get-go. And this stuff is not there yet, but it will be. Pretty much when the total collection of new buildings and building operators start moving towards wellness and health and occupant experience, it'll happen. But it's slogging through the mud, unfortunately, at this point. All right. Yes.
Is there a visualization of the outcomes, the impacts of all of the efficiencies and improvements that you folks have put in, either with or without some of the comfort measurements? Or is that, and including, is that available through the app so that people who work there can easily understand, can see and understand the benefits of it?
Well, let me show you one. Let's go do one and see if I can get this. All right, so let me log in. Some of them do exist now. The softer ones are unfortunately remaining anecdotal. So I still have power, I still have my VPN. There's our building. This is what anybody who would log in live to the web control system. And Tammy, you talked about energy. There's all the meters that we're doing energy-wise. We haven't finished commissioning them all. We're finding that you buy sophisticated meters from people who aren't used to applying them in the manner we're applying them, getting them up and running was a bit of a job. But let's see here. I need to go to, come on, waiting for it to load. All right, I'm going to jump off of this and see if I can drag this down a little bit. And let me just change. All right, so we are, all right, I gotta move it. Excuse me while I manipulate something out of the way. Can I go to the other side, Chetna? Should I be able to grab this? All right, let me just do this. Let me drag it down because I got to get at both of my arrows. So we are looking at energy in the building, of course. Everybody's interested. And so we've got energy from receptacles or process-related energy by tower, by floor, and this is all live. And anybody can log on. I don't know whether you would get it relative to your smartphone, but there are displays active. You walk in the building in the beginning and you'll see this total display right there in the lobby. So right now at the building, it looks like lighting and HVAC are in competition with each other as to who's going to draw the biggest demand. And HVAC's got the most kilowatt hours, so on and so forth. And it must not be sunny down there right now. I've seen this be 370 kilowatts on a bright sunny day coming off the solar panels. So right now the grid is supplying almost all of our power in the building. And let's go back and look at the day. So there's the power usage for the day. And it still kind of surprises me that process power sits here, never goes to zero, doesn't climb a lot during the day. Lighting power, of course, you can see the lights get turned on. And of course the air conditioning comes on, so the total power peaks. This is all trended, it's all available. We haven't set up competitions yet, one department versus another, one floor versus the other, who can use the least amount of power, things of that nature. It's all possible to be done. Now, I do want to show off one thing, because I'm just about at 5 o'clock. I'll keep going, but we have within the chilled water system, come on, open up. We are bench testing a diagnostic, fault detection and diagnostic platform where you're just seeing a portion of the screen. We've logged in 2 300-ton capacity chillers. We've got 9 FDD rules, chillers starting out of sequence, high set point on the VFD. It's not slowing down enough. The chillers are not running on a balanced load, on and on. It's a saleable product. And there we have a high cooling tower approach alert, and it's been there since the building opened. We still haven't figured out what's wrong in the algorithm yet, but either we've got too much sensitivity or we're not measuring the right stuff. So we're trying to watch this building and watch it work and have the building say to the facility staff, you need to go look at this. And apparently you also need to.
So the list is your custom rules for this building, basically. It's the
This is the 21 rules that were developed in our Asia region about 3 years ago and sold on half a dozen different facilities. We brought it over here and we're piloting it. It's here, it's piloted in a New York City facility, and we've also got a large industrial plant in Virginia. What we want to do is say, you bought our chillers, you bought our service contract, we can sell you smart operation of the chillers, we can sell you fault detection and diagnostics for the chillers, We can even sell you a program that watches how much energy you're spending to make the chilled water, and then go over to the building and look at fans and pumps and find out how much energy you're using to utilize that energy, and we will play with set points so that the sum of the two is the lowest number actively, dynamically throughout the day. And there's guardrails on it so we don't ruin relative humidity control in the space and things of that nature. But efforts are saying, I've got data, what am I going to do with it? And
so those rules are kind of standard rules that apply to this type of bill.
Yes, and we could customize them without any problem. And we're running this right now in the web control platform, but we're also uploading it onto a cloud server. We're also embedding some of them into the carrier service organization that wants to know lots of stuff about the chiller, which they do, but they don't have fault detection and diagnostics. They're using it to proactively show up to repair something or to avoid a failure, to only show up when service is needed. We're trying to have them use the fault detection and diagnostic component to increase their value to the customer and not send out service contractors when they're not needed. So I'm going to stop at 5:01. If you want to, shut it down on the web, I'm here. You can come up and play if you really want to. We'll look at the building in more detail, or we can talk over something afterwards separately.
So first, let's thank Bill. Second, I want to ask maybe if there are questions that are queued from the web. Nope, no questions from the web. So last call for web listeners.
I'm sorry, I lied.
Oh, here we go. One from the web.
This is from John Horsington. I'm glad I'm not a carrier iView customer with UTC Center for Intelligent Buildings, highlighting automated logic web control.
I'm sorry, so read the beginning, the first.
I think it was more of a statement.
I'm glad I'm not.
A carrier iView customer with UTC
okay.
Center.
I can respond to John publicly and say that everything that we've done in the building is web control, and iView can certainly run the chiller plant and can run most of what's going on in the building, but the iView backbone is not sufficient to do the integrations with the other platforms. In fact, if I'm not mistaken, ChillerView, which is an iView program, is running the chiller plant. It's only being displayed as a web control. It was part of the total web control package. This is what happens when you market a BAS system through two channels that compete.
So are there any burning questions in the room? Hearing none. So our monthly routine now is we have a period of refreshments and networking. And if you didn't get the memo, today's your lucky day. It's our annual holiday party. So our networking and refreshments will be on the third floor. And Bill says he'll be there, so you can ask more questions to Bill at our reception. Thanks to the people who joined us on the web, and we look forward to seeing everybody in January at our January R&T forum. But in the meantime, happy holidays, and thanks again, Bill Chadwick.
Anybody wants to bounce around in the web control a little bit more, come on up, and then I'll go upstairs after that.
How are you?
I'm well, Ed. How you been? How you looking, Ed? I missed you at the last sleep lecture. You missed a wonderful Amber Markosh gave a sweet lecture for us, following you mentioned a Willis carrier, Eagle Sport, at 9, but you'll get to hear us Sunday.
I know, I was going to say, all the kids, right?
What kids? I'm coming. My wife is coming.
Nice.
Adults come without kids.
Oh, yeah.